So today we're going to be looking at slices through the medulla. Now, at various points of the medulla, just like at various points in the spinal cord, things change and different parts appear and different parts disappear. And so, what I'm going to be showing you is how those changes occur and where those structures appear and disappear. So if we imagine we're at this point here, which is where the spinal cord forms a junction with the medulla, and that's the point where the pyramidal decussation occurs. And that's the bottom section we've got here. So just this section right here. Now, the most important structures that are going through here, we can find anteriorly. So anteriorly, or ventrally, as is more accurately termed in the central nervous system, we've got these structures here, which, as we already said with where our section is at the pyramidal decussation, these structures here are the pyramids. Now you're just going to have to believe me that they look like pyramids. But this is where the corticospinal tract goes. And as we go up the brainstem, it usually stays in this particular location. But at this level, at the level of the pyramidal decussation, this happens. I'm going to be using a different colour, but this happens. And the decussation, which is what I'm drawing right now, is an actual physical structure that you can see microscopically. And so basically at this point, the corticospinal tract disappears dorsally in this particular way. And this is where the decussation is. Now, the corticospinal tract controls our voluntary musculature, particularly in our distal muscles that are controlling our fine movements. Now, that tract, if we follow it through other parts, so the other parts that I'm referring to are at the closed medulla, and the reason why it's called the closed medulla is because, as I mentioned earlier, that's where the central canal is still closed and it hasn't opened out into the fourth ventricle, at the level of the sensory decussation, which is about here. If we keep following the corticospinal tract, it's still staying in exactly the same place as it was before. And likewise, in the upper section, which we sort of level about here, or maybe a bit lower than that, this section that we've got up here is at the level of the open medulla, and that's where the fourth ventricle opens out. So we no longer have a central canal, and you can see the fourth ventricle right in there. Okay? And likewise, in this section, the corticospinal tract, it's still staying in that exact same place. So if we keep everything colour-coded, it's always nice and easy to follow everything and where it's going. But however, you can sort of see in the more rostral sections don't have the decussation, whereas at this level, they do. Now, there are a few other important structures in this particular place. So at the level of the pyramidal decussation, we have this structure here. I'm just going to colour in this way. And this structure is the gracile fasciculus, also known as the fasciculus gracilis, depending on what text or resource you're referring to. And what that is carrying is discriminative touch and proprioception and light touch from your lower limbs. But at this particular point, you can start seeing some other structures more medially. And what those structures are the nuclei. So in here, we've got the beginning of the gracile nucleus, which I'm not sure you can see very well. But the gracile nucleus, as we go more rostrally into the brainstem, we actually find that it becomes bigger. So see how we've got that same structure here suddenly gotten a lot bigger, because now the fasciculus is disappearing and the nucleus is taking over. And the nucleus is where the second order neurons, so the first order neurons from the gracile fasciculus have synapsed onto the gracile nucleus, and the gracile nucleus now takes prominence. And at this point, these fibres are going to start crossing over, and that's why at this section we call it the sensory decussation. So this level is the sensory decussation. And you can actually see it physically here. See these little fibres here? Those are called the internal arcuate fibres. That's where the sensory decussation is happening. And basically those fibres are going from here to another structure that wasn't in the first section. So that structure, which I'm going to colour in yellow, that structure is here. This is the beginning of the medial lemniscus. And so the way that this works out, as I'm sure you know, with lots of other structures in the central nervous system, everything's really well mapped out. So if I have fibres coming from the leg here, those fibres go to the opposite side, but they move ventrally. Now if I go back down and go to the other tract that's really important here, so there's another tract here, which is the cuneate fasciculus. You can't see at this level, you can't see so much of the cuneate nucleus associated with it, but the cuneate fasciculus is coming up from the arms rather than legs. And then you've got the nucleus associated with it, which is sort of starting, but it hasn't really reached as much prominence. But now, suddenly you've got this big nucleus here, okay? And that's the cuneate nucleus once again. And the cuneate nucleus, and here's more of the cuneate fasciculus here, the cuneate nucleus also gives off fibres that go from the nucleus but go more dorsally. So the map is arm to leg. So arm is dorsal and leg is more ventral. And this is important as the medial lemniscus moves up the spinal column. And likewise, once again, we've got the lemniscus, the medial lemniscus here. Sorry about my dodgy drawing. Okay. So I'm sure you can see already there's structures that have appeared but much higher, and there's structures that have disappeared. So what's disappeared is the decussation, but what's appeared is the medial lemniscus and the crossover that happens thereafter. Now, another structure that sort of spans throughout the spinal cord, the brainstem, are these structures here. So what I'm labelling now, which I'm going to label all in the same colour so that we don't get confused. So what we've got here is the spinal trigeminal nucleus. And this is quite intimately involved with the trigeminal nerve, one of the three brothers. And just behind that, associated with it, is the tract. Likewise, it just keeps going up and up. But see how it sort of changes in size and shape? And that just reflects the changes as we go up, because as we continue going up, it's going to be pushed out of the way by other things. Another important structure that is emerging is this structure that we're going to have here. Now it sort of starts off a bit small when we're at the sensory decussation, but this structure that we have here is the beginning of the internal olivary nucleus. Now it's not as obvious at the sensory decussation, but when you suddenly go to the open medulla, suddenly you see this big squiggly line going all around. That's more prominent as we get to the open medulla. And you can see that once those structures push out, and those structures pushing out are what we know as the olives on the macroscopic scale. Now, on the inside of that, at the level of the open medulla, you'll have the fibres that are forming the olivocerebellar tract. And these sort of span up and down, but the olivocerebellar tract connects the fibres from the internal olivary nucleus to the cerebellum, and this is quite closely involved with the learning of new movement.